Hello everyone, welcome to From No to Nothing, Ontological Oxymorons. I'm your host, Joel Bouchard, a doctoral student in psychology, and with me today is Jordan Miller, the founder of Satori Network. As the lead developer of Moontree, a crypto startup, Jordan has blended his blockchain expertise with his passion for AI in founding Satori, a pioneering crypto AI endeavor designed to decentralize the power, benefit, and control of AI. All right, Jordan, thanks for coming onto the show. I appreciate you reaching out to me to be a guest because if I had found you first, I probably would have asked you to be on. You have the kind of background in studying philosophy and being involved in AI and some of the things that we're really interested in that makes you a prime candidate to come on and talk to us.
Well, I'm happy to be here. I found you guys, and then I listened to some of your episodes. And I was like, oh my gosh, this philosophy podcast is amazing. So I'm gonna listen to more.
Nice. I'm glad you found us. So yeah, you and I mean, we just talked for quite a bit before we started the show. So I think we've got a pretty good idea of where we're going. So we'll just kind of lay out for the listeners. Why don't we start with your background, right? You can give us as long or as short as you want of your story up until this point.
I'll keep it short. So I'm the lead developer of a blockchain startup called Moontree, and I am the founder of a crypto AI, distributed AI project called Satori. So I guess my background was in data science. It was in business intelligence. So I did that for a while. Then I became this lead developer. And that gave me some of the skills I didn't have yet to build Satori. So once I had those, I've been building Satori for about 2 years. And it's finally almost ready to launch. Like we're in beta right now. And yeah, that's what I've been doing.
Cool. All right, so we'll define some terms for the listeners before we get into talking about some of the deep stuff. So why don't we start with blockchain? What is a blockchain?
A blockchain is a method of distributed consensus. So this is a new technology or a new ability that we never had until recently. Distributed consensus. If we wanted to come to consensus as a group, we always had to defer to some authority figure, whether it's a bank or a government or something. If we wanted to come to consensus on a distributed scale over the internet, we had to use somebody in the middle. And so blockchain allows that not to be the case. We can come to distributed consensus as a group, or come to consensus in a distributed manner rather than in a centralized manner. So that's basically what it gives us. Like that's kind of the bottom line. Yeah.
Can you explain in layman's terms, right? If you can dumb it down for us, how it does that, right?
Sure. Like the mechanisms by which it works. Absolutely. So, every computer, what it does is it ties authority or who we should trust to work, to the amount of work that somebody has done or some computer has done. So every computer on this network is trying to find the solution to a problem. And whoever finds it first is the one that can, has the authority to create what is called a block, which is basically just a new page in the ledger of what we know to be true. And so it creates this block. Everybody verifies the data that's in that block and says, oh, yes, this is correct. We all know that this is correct, and we all agree that this happened at this time. And now we all keep a memory of it. And we have a record of all the work that had to go into creating this block, this piece of information. So that's the proof of work mechanism behind it. They're just trying to find a solution to a kind of, they're just really looking for a special random number that nobody knows what it is yet. The data, what it is determined by the data in the previous block. So that's why it's a chain of blocks. It's a blockchain. So it's determined by the one in the previous block. And so you can never know what number you're looking for or how to solve the puzzle ahead of anybody else, because everybody is getting one block at a time. Maybe that's layman's terms. Does that kind of help?
Yeah. So what are the practical applications for anybody who's, sort of struggling with the abstract nature of it?
Probably the first one is money. The first one is, okay, we have a ledger. What's the easiest thing to keep track of? And just money. A single number is the easiest thing. So that's why Bitcoin was the very first implementation of a use case on this distributed ledger. You can do other things though. So then you can say, well, we're going to try to implement cash. And that's what Bitcoin is. It tried to implement that. The throughput isn't high enough for it to be cash, but there's all these extra solutions that come on. So what it kind of became was a store of value, and that was really it. But it's a final settlement. So if you have Bitcoin, you don't have an IOU, you actually have the final thing, like you have the gold. You don't have a dollar. So, but you can innovate on top of that. So a long time ago, we saw a whole bunch of other cash, digital cash systems come about, things like Litecoin and, Monero, whatever else. I don't know. But then they said, well, why don't we try to make this a little bit more general computing, and we'll basically make programmable money. And that's when Ethereum came out with their smart contracts, and there's several other platforms that are like that nowadays. And so this more generalized computing evolved. I don't know what's coming next, but distributed consensus, I don't think is done. I think it has a lot more application.
Gotcha. Yeah, so this is definitely an interesting area of axiology, right? Which is,
what's axiology?
Axiology is the philosophical conception of how we determine what has value, right? And I think that this is something that still hangs up people older than me, right? When it comes to crypto, right? They go, well, why would I ever trust this stuff? Because it's not real money, which, sort of turns a blind eye to the fact that, the greenback is no longer backed by gold. And then on top of that, what gives gold value? And, it's turtles all the way down, right? How do we determine what value is, right? So when it comes to blockchain, right, determining these, running the calculations to find these numbers, what gives crypto value? What gives these numbers that all the computer processing power is going in to find? What makes that valuable?
Well, I don't know this, what the philosophers have said about this term and what they've tried to deduce about the fundamentals of, what was it, axiology?
Yep.
But I would assume it's really whatever they say. So this is how I've kind of conceptualized it myself. What gives anything value? I don't know. Do you have any idea on that?
Well, and that's the question of aesthetics. It goes all the way back, right? Is that these value judgments, right? How do we determine them? And really, it goes beyond just value in terms of monetary value, all the way down to the very essence of good and evil, right? Do good and evil exist in the universe? That's a value judgment, right? Because some people would say, well, certainly, right? If I were to go out and do something terrible right now, if I were to kill a bunch of people, we'd say that's evil. But if you zoom out far enough, right, into the grand scheme of the universe and all of this sort of thing, and you look at the ledger and everything else, you might go, well, no, it's kind of all meaningless, right? people die all the time. People are born, everybody's gonna die. Like, is it evil? Does good or evil exist? So axiology, this idea of what gives something value, there's been a lot of philosophical positions on it, right? But I think from a practical point of view, we can, look at our stock apps, right? And we can see Bitcoin or whoever, go up and up and up in value, then go down and then go up. So there is some practical value to these things. But I think that some people struggle to grasp why that is, right? They can see the value of $1 because it's backed by the US government. So you go, well, as long as there's a United States, this dollar has some buying power. It has the ability to get me something.
Right.
When it comes down to it, the necessities, right? I can get food and shelter using this thing to exchange for goods and services. Now, cryptocurrency is also inserting itself in that way. But why? Why is
I would say, oh, sorry.
Yeah. No. That's pretty much it. Yeah. What do you think?
I would say, let's just look at that. Is the dollar backed by the US government? First of all, I mean, what does that really mean? Okay, so the dollar used to be backed by gold. That kind of makes sense because then you're like, I would rather have gold. I'm going to save it or whatever. I don't know. So everybody wants gold, right? People in the US need dollars to trade here, and other countries, you need their currency to trade there. But if you got gold anywhere in the world, you got something people would be willing to do something to get, right? So gold is kind of like that final settlement or that, the intrinsic value is it's just universal value, really. It's not intrinsic. It's universal. Everybody wants it. And so that's what I kind of define as value is what do you want? It's whatever you want. And a lot of people want this. So if I have this, then they can, I can get them to do things for me that I want so that I supply their dollars. They want dollars. So my attitude is whatever we want is what value is. Value comes from humans wanting things, right? It's will. So when I hear people say something like, oh, the dollar's backed by the US government, that doesn't really mean much to me. It kind of made more sense when it was gold, like I said, but I kind of think, no, it's not backed by the US government. It's printed by the US government, and the US government has a lot of guns and they do a lot of things. But, I don't really buy anything from the government, right? I pay my taxes to them in dollars, but I don't buy their, any real goods. So it's not really backed by the government. What it is it's backed by other people's labor that are willing to go get it. Now, they might want it because they think it's, valuable because the US printed it and, we're powerful or something. I don't know. But really, it's backed by the labor. It's a proxy for other people's labor. Really, that's all it is. And so Bitcoin being an abstraction of value, it's literally that as well. Other people want it, so it's valuable. And why do they want it? Because it can't be printed into oblivion, because there's a limited supply.
And that's what I was going to get that's what my thought was as well, was that, what made gold a powerful backing for currency is that it is a finite resource, right? Yeah. You only have so much of it. Whereas, we can see the situation we're currently in America with rising inflation, where, as you mentioned, without the dollar being attached to anything, you can just print more and more and more, but then the value of each one cheapens. And I understand. I get the point you're trying to make. It's a little bit nuanced, the backing of the dollar versus the representation or the tokenization of it, right? Which is essentially what it is. But I think that's the main question I was trying to get at was, so Bitcoin is a finite resource, but what is the value of it, right? Why do people want it?
right? It's a finite resource, and you can do something with it that we've never been able to do before. And that is trade it or send it to somebody over the internet without anybody being able to stop you. Or you can get it from somebody without anybody being able to stop you. So it represents control over your own money. So it's control. It's control and it's limited supply. And I think those are probably the two things. They're functionalities, right? So it's not going to be inflated away like the dollar. And you can control it directly like it's gold. So, you have dollars and the government doesn't like you. They can seize your assets or whatever. They go to the bank and say, hey, give me that guy's money, right? So they can't do that with Bitcoin. So it gives you more control. And I think that's what people want, is they want that kind of functionality.
So is there any inherent value to the calculations the computers are performing? When the computers mine for Bitcoin and they find a number, right? They have a block. Does all of that processing power go into achieving something that's of value beyond obtaining the Bitcoin?
No, it doesn't. It just goes to secure the network. That's all it does. And so everybody saw this as a problem, or at least a negative situation, right? A cost, right? They saw it as a cost. It's a cost. It's a high cost. It's not an astronomical cost, but it's high. And what if we could do that and get something else out of it at the same time? People have been looking for that. And so what they really looked for it at the beginning of this industry hard. So they had things like, I don't even remember all their names now, but they had several different innovations. I think one might have been called Peer Coin. There was another one that was looking for prime coin, I guess is probably what it was called. And so there have been some more innovations where they're like, well, why don't we do something useful? It's not as controllable as this hashing algorithm, though. It's, it doesn't, you can't make it fluctuate as easily. It's, not as manageable doing any of these other things. So what the industry kind of went to was like, you know what, we're just going to use proof of stake. Proof of stake is the same thing, but those that have token rather than those that have are doing all the work, have compute power, are the ones that can make blocks, essentially is what that is. So we traded proof of work for proof of stake in a lot of systems, not all of them. And the industry is pretty much okay with that. Everybody's like, well, that's, it's energy efficient, so we're just going to use that instead. It's not as secure, you might argue, but it's much, much more energy efficient. Now, my solution is what we should probably do, back in 2013, I tried to make this Satori project at the bottom. I tried to be one of these innovators that could build a new consensus mechanism or a modification of the proof of work algorithm to make it do useful work. And it was too hard to do that. So this was very, very hard to do. Sometimes it's impossible. So what I wanted to do is make a proof of prediction algorithm. And you can make that, but you can't make a proof of prediction about everything algorithm. And it's hard to scale, right? So you can make it, but it's just not as useful as it needed to be. So when I wasn't able to make that proof of prediction algorithm, I kind of put the whole idea on the back burner and said, yeah, I would like to build a network that predicts the future using AI and blockchain, right? I would love to do that. But I don't have the skills or knowledge or understanding yet to be able to execute on that. So I'm going to go back into my career and try to level up my skills And I finally felt like I could see the end from the beginning on that 2 years ago. So that's when I, started building it.
Cool. Yeah. So why don't you tell us a little bit about Satori?
So Satori is a worldwide network of AIs that are all talking to each other about the future. So they're trying to predict the future. So, I saw this early on. Intelligence is very powerful. Knowledge is power, and things have a tendency to centralize. And we really should fight against the centralization of intelligence as such, So, because then whoever has control over that has all the power. So, I saw this early as we should probably decentralize intelligence, or any aspect of intelligence that we can decentralize, efficiently, as fast as possible. And I saw future prediction as one of those domains. So Satori is a network of computers that are all predicting the future and trying to come up with a world model that understands how the world will evolve, and that, the environment, that also means our society, our money, our governments, our, industries, and like our attention. Like, how is our language evolving? How is our memes, our thoughts, our ideas, how our value hierarchy is evolving, So I wanted to build this holistic worldview of human civilization and predict the future of it, so that, we can see the future before it happens. Because if we don't have that, which we don't right now, but soon, that's a problem. Because I thought, well, here we are. We've evolved, in the savannah, we mastered the physical world where we can live in any climate, no problem, right? And then we created like tribes and tribalism, and we made, the societies, and we got all the way to nation states without blowing ourselves up yet. And so that's, not bad. We basically had to evolve in the social environment, right? Physical, then social. And now we're needing to evolve in the technological environment, starting with maybe, the Industrial Revolution. We've been on this kind of track. So, and now it's evolving faster and faster. The technological environment is evolving faster and faster. And the social can evolve faster than the physical. And so we've been through this. Now we're getting to a point where it's really exponentially fast, and we should probably have something in place that lets us anticipate the future before it happens, or we're all going to die, is kind of the idea that is, it's possible. So that's one of the reasons why I'm trying to make this thing, not only to decentralize AI, but also let's see the future before it happens. Let's build a future oracle, is the whole idea.
That's an ambitious project.
Yeah.
So how does it work? Do the AI that are connected, do they talk with one another? Are they like bouncing ideas off each other? Are they trying to triangulate the future based off of the views of each of them? Or how does it operate?
That's exactly right. The nuance behind that question might look a lot different than, kind of just off the cuff, what you might think. So let me go into that. I mean, people might think, okay, AI is language nowadays, right? These large language models, when we say AI, that's like 90% what we're talking about. So AI is language to the average person. I've been through this, watching this industry as it evolved through, it wasn't like 10 years ago. I don't know, maybe 15. When people were saying, you know what, neural nets, really, there's all these winters. There's really no future in neural nets. And now it's, the deep neural net revolution. That was during the deep neural net advancement. And I was like, no, you can't do everything with support vector machines, So we've been evolving what we call AI or machine learning for a while now. And you can make all kinds of models. A large language model is one type. But all of the cool models these days, all of them are built on neural nets. So what you might think is that the machines are all talking in English to each other, right? That might be the naive kind of, and essentially that's accurate, but they're not actually talking in English. So what they do is they go out and they watch something in the real world. It's a network, so each node can watch a different set of things. So, some nodes are watching financial markets, some nodes are watching the environment, whatever, doesn't matter. So they're all watching a lot of different data streams that are happening. So a data stream is just something out there that we're measuring again and again and again and again and again. And so the value changes. And so it could be sentiment on Twitter, could be the price of gold, could be whatever. So they're out there, they're watching these different things, and then they're predicting the future of what they're watching. So they start watching something, they get a feel for all the patterns. How does it move? What is it correlated with? How does it move in its environment? The patterns within it and across data streams. And so they're learning about these patterns. And then they start to predict the future. And what they do is they just broadcast that future out to anybody who wants to hear it, including other nodes. So this is the bottom layer, the simplest version of their coordination. They can just broadcast the predictions. And so they predict, this is going to happen in the environment. And the nodes that are watching the price of wheat say, oh, well, in that case, let me revise my, what I think the wheat yield will be this year or something. So they're all just automatically making these models of whatever they're looking at and broadcasting out their predictions and finding correlations between the data streams. That's what we've built so far. And that's the most basic version of what this thing can be.
Gotcha. So all of these things, they're looking at their own separate picture. They're looking at trends, patterns, predicting where that trend's going. And then on top of that, they're communicating with, the economic and the environmental and the political, all these different ones are then communicating together and bouncing it off each other. Have you received any output? Like what sort of things have you seen come from this thus far? Or is it not kicked off yet?
We don't have, what we've been focused on is getting the infrastructure in place, So, we have some data streams, but they're not probably the data streams that really matter. We're like predicting some crypto prices and basically whatever data streams we could test the network with. That's where we're at this point. And so we don't have enough nodes to make a world model, and we're not listening to enough streams. So we're not quite to the point where we can get any kind of broad overview. Like you said, all of the nodes are supposed to look at the world as one object, but all do it from different angles. And that's kind of how our brains work. Not only our separate individual brains, we all have different occupations or interests. So we're all looking at the one existence from different points of view, but also our brains themselves. We have different regions that specialize in different kinds of modalities, our vision or audio, hearing, different kind of thought processes. Here there's a region that generates language, so our brains are kind of doing the exact same thing that this network is doing. And that's the exact same thing that we as a human species do in order to, survive. Sorry, I think I went off on a tangent, but that's what they're trying to do.
No, that's good. And I've got a question that comes off of that, right? So looking in psych, you mentioned regions of the brain associated with language, right? So you have Broca's and Wernicke's area, right? So if you have an issue with Broca's area, but not Wernicke's. You might be you'll be unable to speak, right? But you'll be able to write words. If you have a problem with Wernicke's area, but not Broca's area, you can speak, but it's all nonsense. There is no actual words. It's just a bunch of jumble, right?
Wow.
So that's kind of a demonstration of if you have one of these nodes that isn't working or is missing, right? The output is almost useless, right? So from translating this to Satori, how do you know when you have enough input streams to correctly predict the future? Is it just the sort of thing where you put a bunch of streams together and then you look at the prediction, and then when the time that has elapsed has gone, you compare the prediction to the real output? Or
yes, that is how they kind of see how well they're doing. Is they wait for the future to happen, and then they can see it. And so, and then as far as like how many data streams do you need? I think the right approach is just to start with the most broad data streams. And, that's going to be a small number. And then as you get more and more, computers on the network, participants, then you can increase kind of the detail of what you're looking at. So, So I think you can get started with a pretty small number of data streams and nodes.
And is the participation, how does that work? Are the AI developers voluntarily offering it, or are you just taking advantage of the services that they offer and integrating it into a new, into Satori as a separate thing? Or how do you go about enlisting the services of the AI?
So a lot of systems, especially systems that try to combine blockchain and AI, they don't really combine blockchain and AI. Some do, but a lot of them require a lot of human labor to make it work. And maybe that'll just go down over time and it's not a problem. But our system is fully automated from the beginning. So anybody who wants to download the Satori neuron can just run it on their computer, and it has an engine inside of it that is in charge of building the models and understanding the data, collecting the data, figuring things out, broadcast. It all happens automatically. So in this way, it's analogous to, but not directly, compatible with or whatever, mining, crypto mining. So it's analogous to crypto mining. And back to your question about the usefulness of crypto mining, this is not going to secure the blockchain in that way, this mining activity, but it is useful work. So like when the computers are running, they're building these models. Those models stay on that computer's machine and they don't go anywhere else. So they don't get aggregated, they don't get sent up or shared. What does get shared out is the prediction of the future that those models produce. So I think that's a valuable thing, that it's building, hundreds of thousands of models in parallel to understand our world, and it doesn't really take any human labor. Now, it takes our labor. We're building the engine. We have to continue. But since we're focused on a narrow domain, narrow enough of future prediction, we can build an engine that automatically builds these models. We don't need to enlist an army of data scientists to build these models for us.
Yeah, no, you can definitely see the value in that, because it goes back to what you were saying earlier about decentralizing intelligence, right? And the dangers associated with centralized intelligence, but also the inherent value in being able to predict, at least with some degree, right, the general trends of the future, right? To know what the impacts of climate change are going to be, or what financial markets are going to do, that sort of thing. That definitely has value for humanity as a whole, right?
Right.
So I think that it is easy to see the value in it, and it seems pretty ingenious the way it's been set up to be automated from the start, because not a lot of people I think are aware of it, right? But yeah, there's an inordinate amount of human effort that goes into training AI models, and as a matter of fact, it's one of the few places where philosophers tend to have a real niche in today's labor market, is that they've been sort of enlisted to train some of them and things. So,
oh, cool. I didn't know
yeah.
that.
So it's interesting. I appreciate you giving us the deep dive on that. It's super cool, and I would love to keep talking about it. But I also don't want you to make you feel like you're at work. So, if you want, we can move on to something a little different. And we had talked before the show about AI, right? And so we've been talking about that a little bit, how it works and the blockchain, that sort of thing. So when it comes to AI, I think that there's sort of two general feelings that most people get. One is this sense of, the vast possibilities of the technological future and all of the doors it can open and all the problems it can solve. But with that is the double-edged sword of, how do we measure intelligence, right? We talk about decentralizing intelligence. How do we measure intelligence, right? Because this is even, I can tell you from a psychological standpoint, this is an unsettled question in humanity, right? There's the camp that says intelligence is a single construct and that we all have a certain amount of it. There's some people that say that no, you really can't define it that way. Intelligence is several different constructs, up to a dozen or 24 different things, and you can.
You're talking like emotional intelligence and
yeah. And so there's been theorists who have come up with a dozen different types, and
Sure.
talked about people having more or less of one or the other. There's people who have this sort of static trait view of it, that you're essentially born with a certain aptitude and you can develop it to a certain extent or not, but what you get at birth is what you get. There's other people that say that's not true at all. If you give somebody the correct environment and the correct training, they can go beyond it. So intelligence is this very difficult question in the human domain still. And now we're talking about applying it to machinery, right? And then along with that is the concept of consciousness, right? And people's the other side of that artificial intelligence coin, right? Apart from the possibilities and the innovations and things, is this fear that people have, right? That Terminator is going to come true or whatnot. So what are your views on AI generally?
Oh boy. Optimistic. It's a technology. I don't really, our brains are a technology. That's how I view them anyway. I don't know if that's philosophically accurate but that's how I see it. So I'm like, well, our brains are implementing an algorithm, some kind of algorithm, some kind of, computer that produces our intelligence, right? So we've taken this, we'll make a black box for intelligence, and we'll say that algorithm, whatever it is implemented on the human hardware through the nervous system, right? So, and what we're doing is we're figuring out how to implement it on computer hardware now. And so it's the same thing, in my mind. It's not built the same, and it doesn't do the same stuff yet, and one's much more advanced than the other. But, we're trying to get there, right? We're trying to get to what we are and then beyond what we are. And we're not going to build the exact thing that we are. We're not going to build that because we already have us, right? We're going to build other things, but we're going to make them intelligent. So if we wanted to make a machine that can fly, we don't build an exact replica of a bird. We take the operating principles that, a bird uses in its wings and all that, and then we apply it to our technology, what we have to work with. We're using metal and whatever else. and we create planes. So I have been interested in the fundamental operating principles of the brain for a long time. That's kind of what I was most interested in, when I started getting interested in stuff. So, because I felt like we don't need to build what we are. Evolution will tend towards that or something like that by itself. Don't worry about it. But we do want to know how we work. And I think a lot of AI researchers or a lot of AI, practitioners or whatever, they kind of come at this more heavily aware of the limitations or the strengths of the technology itself, right? Of over on that side. They've been looking at AI, artificial intelligence, for a long time. Whereas I started looking at I wanted to know, what is intelligence as such? And the only, the best way that I can come to that knowledge is through the human brain or through as abstract thought as I can get. And so I tried to learn the hierarchy or the principles of the brain, that how does it create intelligence, and then take those principles and very broad strokes and apply them to the technologies that are evolving today. So I guess I view it as a technology. I'm not worried about it. I am worried about the centralization of power, but I'm not worried about AI as it is. And I tried to define intelligence, because you mentioned like people have been trying to define it, philosophers or academicians or something, for a long time. And they've come up with this debate of, is it one thing, is it multiple things? Having a computer background and kind of being interested in data and data science and how information works, I kind of look at it from that perspective. And what I've come up with, I haven't really heard of much everywhere. I'm always trying to look for what's the simplest, most direct, most accurate framework for, whatever I care about. So when it came to AI, my framework looks something like this. First of all, it is a network. We have to view it as a network. And I think the reason for that is we have to view everything as a network, because anything can be modeled as a network. That is like a universal way of modeling information or data or anything we can see or anything. So what do? We say, well, there's atoms and there's lots of different kinds, and they interact with each other in this way. So now we have a network, right? Their interactions with each other. And then we say, well, we also have molecules. They clump up and they form molecules, and those molecules interact with each other in various ways. And then they clump up, and then we get biochemistry, and I can't even imagine what that is like. So we get all this complexity, but we have this hierarchy of networks, one on top of the other. The brain is structured this way. So at the very bottom, we might say, okay, we got neurons, and they're a network. We have this huge bundle of neurons, and that's what we are. And so we're this huge network. But we could also say, they figured this out in like the 60s or something. Those neurons clump together in little units called mini columns. And those mini columns clump together and they kind of form a network, and a higher network of cortical columns. And in those cortical columns, you could say, well, they're clumped together in different regions, like we talked about those regions. And those regions talk to each other. So they're a network. And those regions are arranged on hemispheres of the brain, and there's two of them. So at the very top of this this networked hierarchy, you have two nodes. You have a network of two. And at the very bottom, you have a network of, trillions or however many, I don't know, billions probably, however many neurons we have. So So I would say, first of all, let's recognize that we can whatever we can model in our brain has to be able to be modeled on a hierarchical network. Therefore, a hierarchical network is the fundamental modeling language of existence itself, because, we define existence by what we can experience or what we can even think about. So we can't do any better than that. Maybe a theoretically better solution exists there, but we can't see it because this is all we can build.
Yeah.
So I would say, first of all, we should recognize that. And then we can recognize other things like it seems like intelligence, we just look at what evolution does. It seems like intelligence is the act of a structure, computational structure like that, like the brain. It seems like it's the act of nature to conserve the bandwidth or efficiently use the bandwidth. And so where more data has to flow, we see more neurons in the body. You've got a lot of neurons that go from your hands to your brain. And we don't have as many neurons that go from our back to our brain, right? So we don't feel as much on our back because we don't need to. We're not using them all day. So where we use a lot of information, we need, kind of thick wires. So it seems like that's what intelligence comes from or tends towards. But anyway, that's my kind of homegrown definition of intelligence.
Yeah, I like that. There's a lot of interesting stuff in there. And I think that it's sort of mirrored in Satori itself, right? Because I think that if what I'm gathering from what you say is correct, and you can feel free to correct me if I'm wrong, but intelligence would seem to be the identification of networks, and then the most accurate utilization of those networks that reflects functionality in an environment, right? So if we have this distributed network, and like you mentioned, that's how we learn, right? We get these nerve impulses, and those impulses are what cause our dendrites and our axons and all of our different neural material to grow and to function more efficiently, to myelinate and things. If that learning occurs in a way that is beneficial to our survival in our environment, then we tend to thrive. And so that can take a variety of different sort of manifestations, I guess. It could manifest as purely physical survival, but it could also manifest as adept maneuvering in social environments. It could manifest as making good financial choices based off of, again, predictions about what the future may be like. And so all of those things, I mean, if you start to piece them together, that begins to look like intelligence, right? The recognition of networks as being the fundamental unit of how an organism operates within an environment and the larger environment of our reality. And then the sort of effective distribution of those networking resources in order to optimize how it's employed. And I think that seems to hold water to me. That kind of makes sense.
Yeah, doesn't it? I mean, it feels right. And then all those different, like you said, maneuvering socially or whatever, all of those seem to be the expression of will. So, yeah, I mean, the question is, okay, if you exist in time, what kind of computation can you do? What kind of patterns can you recognize? What kind of data can you model that will probably give you a good way to express your will, right? And to me, it seems like, well, if you exist in time, knowing the future is the most direct route to being able to express your will. You've heard of that. What is it? It's a thought experiment called Maxwell's Demon.
Yeah.
And so, I mean, maybe you can explain it better than I can. I don't know. Do you want to try or I can do it?
Go ahead. Give it a shot.
So what I don't really, know it very well, but what I take away from it is that Maxwell's like, okay, we got to understand entropy and, we're trying to figure this out or whatever. He says, if we have a demon that is in an environment, some entity that's in an environment, and it wants to put the environment into a particular state. And it knows the state of the environment down to its, most fundamental level. It knows where every atom is. It knows everything. And it knows how it will evolve because it knows all the rules of the environment. Okay, so we have this little demon guy who's in there. He knows everything, and he knows if he doesn't touch anything, he knows exactly how the system will evolve because it's a deterministic system, right? And then he also knows that the result of any movement that he makes, the result of any change that he effects. And so, because he has all this perfect knowledge of the environment, essentially because he knows the future, he has the ability to mutate the environment from the state that it's in right now into any state that it can be in the fewest number of steps possible. He will never make a mistake, right? And so this is kind of the Maxwell demon. And there were other conclusions and isn't this weird about this or whatever? I don't remember all those, but I do remember kind of the thought experiment itself. And my thinking is, yes, it seems like intelligence evolves as its main function to be able to predict the future. Because whatever, there's a lot of patterns out there in the world. There's a lot of patterns in our vision. There's a lot of patterns everywhere. The whole world is patterned. So what kind of patterns do you need to model in order to be able to have control over your environment? And it's like, well, whichever ones allow you to predict the future the best, seems like they're the ones that give you the most control. And so future prediction seems like it's almost the backside of control. It's almost the same coin. But anyway, maybe that's...
Yeah, you've touched on a lot of things that longtime listeners are going to be familiar with. We've done some episodes this year on entropy and Boltzmann brains.
Oh, cool.
And determinism and these sorts of things. And so it raises, there's very interesting philosophical thought experiments that arise from this. And so one sort of aspect of this, right, is if you take an empirical, reductionist, materialist viewpoint of the universe, then you have physics, right, which essentially says if we knew what the initial state of the universe was, we'd be able to just play the tape forward and we'd be able to predict everything, the future, right?
Yeah. Totally.
And then on top of that, you have chemistry, which was sort of what you were mentioning earlier. You have atoms, you have molecules, you go up. So you go from physics to chemistry to biology to psychology. And if you have an empirical reductionist viewpoint of the universe, what you essentially are saying is that psychology is nothing more than applied physics, right?
Right.
Because if I knew the initial states, if I knew everything about the minutia of the material world, then I'd be able to predict or explain everything, and human behavior included, all the way through to the end of the universe.
Totally. It's deterministic at that point.
Yes, and so it's deterministic, right? And this is the fundamental scientific paradigm, right? Because questions of science are necessitated by empiricism, right? And this is a good thing, right? I will say outright, this is a good thing. That's what you want from science, is to be able to empirically come to epistemology, right? Knowledge of things. But it does create this sort of tension or unease with people when you open up this specter of determinism, right? Oh, so what you're saying is that essentially I have no free will, right? If we could know everything about the physics of the universe, you'd be able to just play my life and see exactly how it would turn out. And there's been a lot of psychological studies, and especially in the criminal justice region and things. So looking at people and trying to predict what their life outcomes will be based off of certain early experiences and these types of things. And you can see with a certain degree of probability, high in some cases and not so high in others, how people will turn out generally. And that really makes people uncomfortable, right? And so this idea of an AI, right, like the Satori network, right, having access to this information, but being able to utilize it at a scale and in an efficient manner that's far beyond what science can do, right? Because when we're looking at how the human brain works versus how a neural network works, is the human brain is just incredibly slow. And the reason for that is because the human brain is not an electrical system alone, but an electrochemical system, right? We have neurotransmitters. So you have the electrical pulse that travels down the neuron, it gets to the synapse, and then you have this process where you have to release a neurotransmitter that has to be uptaken by the next synapse, and this is a slow process. So
way slow.
Yeah, and so neural networks don't have to do that. They're just all electronic things, zip around at the speed of electricity. They have many more connections, and so the processing power is far beyond what the human brain can do. What do you think about that? Are you a determinist, right? Do you see reality as being sort of accurately portrayed by empirical reductionist, materialist, monist viewpoint?
What's
and if
monist?
Monist, monist is the view that everything in the universe is made up of one thing. So in other words, atoms, right? So a dualist, right? If you're a Cartesian dualist, those are the people that say, okay, well, my brain is like sort of the antenna. It does the work, but really my consciousness or who I am exists outside of my brain. And whether you take that in religious directions or, sort of other directions, it's just basically just the idea that mental stuff is separate from physical stuff, whereas a monist believes it's all physical, right? So yeah, what's your viewpoint on that, and how do you think that Satori, as you see it, sort of evolving into the future, how would that affect our interactions with how things go down?
First of all, Satori being able to predict everything, de-silo all the data, understand everything in the context of everything else. That's a lot of power. So that should be decentralized, So I just wanted to mention that before I get into it. That's why we need to decentralize it. Okay, so I hope we have kind of a head start. Nobody's trying to do Satori yet. Nobody's thought, oh, this is a good idea. So I feel like maybe we can decentralize this one, and if we can, let's try to do it. Okay. So, but determinism kind of you asked, am I a material reductionist, right? Is that?
Yeah.
I'm not anything, because I learned a long time ago. One of the big life lessons that I've gone through is to avoid, when you can, choosing to believe something. Sometimes you can't, because and certainly avoid identifying with any kind of name, of any kind. Because as soon as you identify as a name, an identity, a name is kind of a concept that is approachable by the lowest common denominator. So it doesn't have the nuance it needs to accurately represent reality anyway. So, and then once you do it, you're kind of like bound to that name, and you're like, well, I am this, and so then you get defensive, and it's better just not to believe, just don't believe things. Just be open to what is. So that's what I try to do. Probably too much, because there are some things that are like, no, this is obviously like accurate, but still, I'd rather err on that side because, as a kid, as a young child, I have adopted the religion of my parents wholeheartedly, right? So I was this little fanatic, and I had to go through that experience to realize these lessons. It's a bad idea. Don't do it. Don't believe anything. So I try not to believe. Now, what I will say, though, is you have to build interim conclusions. You have to live your life. So you have to have some kind of operating conclusion that you're operating on. But I always at least recognize that everything I think is true might not be true. So I think if we all did that, that'd be a good idea to do. So that's kind of a premise to that question. I'm not anything, but I would say I went through a period where I did really think about determinism and material reductionism deeply and considered it. And I did have this problem with conscious experience saying, look, dude, how do you get conscious experience out of it? And I know Daniel Dennett's gone through it, and lots of others, right? Philosophers talk about this. And so being a layman, it's not like I went and read everybody's thoughts about this. I just kind of tried to reason it out myself. And I said, it's a really interesting thing because I sleep and I lose conscious awareness, or at least most of it, probably all of it. I don't know. And so it seems like it's all physical, but then at the same time, I can't see how it would ever happen if it was all physical. And so I've gotten to a point, well, here's what I realized. I was going for a walk one day. I like to go for a walk at least once a week, kind of go on a little hike or something. So I was out there thinking about this, and I thought, okay, if I could get the initial conditions of the universe, I'd be able to predict the whole universe. All right, we're going to accept that. But then I thought, well, I can't. Not only can't I, it probably didn't have an initial condition. Maybe it did. Probably not. So not only can I not know it, but it probably never existed. And if something recedes to an infinite past, if there is no initial condition, then there's, it's fundamental that uncertainty is baked in. And we already see that. We know about the uncertainty principle. We know about Gödel's incompleteness theorem. So we know we can't build a language that describes reality. And that just means we can't build a model that's accurate. And so no model is accurate to reality. Nobody can know anything for certain. And so what I realized is I need to relegate this deterministic thinking, which is my natural thinking, despite being very religious as a child, I was very analytical and very scientific about things. And so it's my natural, I would naturally be inclined to be a material reductionist. And yet, given that I can't know the initial condition, nor does it probably ever exist, we can't get there. So I said, I need to relegate material reductionist thinking, basically determinism, all determinism, to the realm of language. I need to relegate it to the realm of modeling. I need to relegate it to the realm of ideas and abstract concepts. And that's where we can use determinism. It's math. It's not the real world. It's not. So I would probably say no, but it's the most useful tool we have to understand the real world. And so we divide things up and we model things deterministically, and that's the best model we can come up with. But it's not accurate.
Yeah, I think that's a brilliant answer. That's a master class in philosophy, right? And I've said almost that exact same thing word for word when I'm a guest on other people's shows, right?
Oh, cool.
Which is it's just material reductionism, empiricism, monism. It's scientific, right? This is how we come to know things. But just because this is the only solid way we can come to know things doesn't make it the be all end all, right? And so there's two things going on here, right? Like you said, it's the most effective tool we have for gaining knowledge. And it's a framework, it's a model that works extremely well. And so from that point of view, epistemologically, and it helps us understand the world around us. But there's inherent parts of the world that are inaccessible to empiricism, right? And human experience is certainly one of them, right? And that's the problem with trying to study consciousness is that consciousness is inherently subjective, whereas science is inherently objective, right? And so when you're trying to determine how subjectivity arises through objective means, it's just incompatible, right? It's just not
a much more succinct way to put it.
it's just a construct that is inaccessible to the investigative paradigm. Yeah. It doesn't invalidate the subjective or the idea of consciousness, which I think is where empirical reductionism sort of falls, right? Because I think that people can have a religious faith in science, right? Hey, if it's not scientific, then I'm not believing it, right? And I think that can be flawed if you're taking it literally. But I think that if you're operating from the position that science can provide us real answers in the domains that it's accessible to, and in the domains where it's not accessible, we have to be open to the fact that we aren't going to know, that there's going to be mystery and uncertainty built into the universe. Because much like you said, language, there's no part of language that is able to capture the abstraction that it's attempting to cover, and the 3 pounds of meat, the meat machine in our head is completely not up to the task of trying to parse these things apart. And so, long story short, the universe and reality is a much bigger, more complex thing than we like to admit, and we'll just never know. I think that's the reality of the matter, but it's something that really scares people. Anybody who does have beliefs, right? Because I'm very much like you. I go on shows and people ask me, what are your core beliefs, right? And I always tell them one thing. I said, my core belief is that I'm always willing to change my beliefs, right? Nice. If there's new information, right? If there's new information, new evidence, I want to be able to adjust what I believe. Yeah. But that's a scary proposition to most people. And it's not the way that our brains are evolutionarily hardwired. So it's a difficult thing to do. So
it's a lot of work.
Yeah, it really is. So I appreciate your response. I've had so much fun talking to you today. I really hope you can come back because we just scratched the surface of things that we could talk about, and it was so interesting and so much fun. But I appreciate you being on. Do you want to? I know we've talked about Satori quite a bit. Is there anything else you want to mention or plug before we go?
No, I only go on podcasts to talk about Satori. The thing is, I'm really interested in philosophy and thinking and how to how to divide up the world. I'd love to come on and talk about that kind of stuff again. But yeah, I've only been reaching out to podcasters or getting on to kind of get the word out about Satori. Nobody knows about it. It's brand new. Nobody's doing this. There are other AI blockchain projects, but they're not engineered this way, or they don't have this kind of vision, I don't think. They're mostly like, small ideas. Much simpler, not ambitious. It seems like to me. And that's okay, Well, frankly, I think most of them don't know what they're doing. They're like, well, we just want to get into the space, So
Right.
they don't have a plan or anything. So, or a reason to do it, right? So that's okay. I'm welcoming them. We should do as many experiments as we can. But I hope people see Satori as something that can matter, something that can give us a heads up about the future, something that helps decentralize it so that it's not in the hands of, Google or anybody else. It's kind of in the hands of whoever's running nodes, and they can run it any way they want, and they can manage the attention of the network. Our whole civilization, it's all attention. We live in each other's minds. And so that's all there is attention. And it seems like if you can manage the attention of this network that does nothing but predict the future, that's a valuable thing. I think that's a useful thing. And so we need to decentralize that as fast as possible. Anyway, that's it. Yeah, that's the talk.
Well, I know that knowing our listeners, you have everybody hooked, with what you've said today. And even that, the last thing that you said, I just want to go into so much more on it. But we'll have to save it for another episode. But I hope you'll be back on. And until next time, keep pondering.